Hey everyone, Steve here with 836 RoboBees here in the Newton division with their amazing robot, winners of the Chesapeake DCMP, and I'm really excited to get down with their amazing robot that they have, currently 4th place in the Newton division, so they're up there, and I'm really excited to talk about their over-the-bumper intake, especially their amazing shooter and climb mechanism. Really excited to get down here on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
Colin, talking about your design process that you have with your robot, why did you choose over-the-bumper intake?
Yeah, so our team just has a lot more experience with over-the-bumper. And we decided this year that under the bumper was a good idea because of the fighting over the center line. But we decided that if we could just put our effort and experience into making a really solid over the bumper, that it could be better overall instead of having to figure out a whole new thing with the under the bumper. This intake and a lot of the parts of our robot have gone through a lot of revisions since our first competition, just making them more robust and like our first competition, we had a lot of issues with reliability, and it broke pretty much every match. But we were able to up the size of the sides, put in the aluminum skin, up the thickness of our intake rollers, the steel shafts on the insides, and we were able to get it really solid. So we're happy with it. Another thing that we've changed a lot since our first competition was our climb. We used to have it on have a bar here between our two climb hooks, and that meant that we had to put our shooter up before we could climb. But we changed to have this mechanism on the inside where it pinches the wall of the box tube, so it doesn't need to have this bar here, and we saved some weight there, and we made it so that it could go a lot faster. This robot has just gone through a lot of revisions since the first competition, just making it more robust and better at doing stuff.
Now, I also see that there's a bit of a middle mechanism for the flow of the note. What is that middle mechanism? I assume it's your amp and trap mechanism?
Yeah, that's part of our amp and trap mechanism. We have a decision wheel here. So you look here, the note goes in, and it either goes under the rollers, spinning one way, or it goes up this way if the rollers spin this way. So we're able to decide based on which way the wheels are spinning, where to put the note. And because of that, we can transfer it between systems really quickly. So our driver intakes it, and it can go into the shooter, and then we can switch modes, and it'll just go into the trap automatically. Because of the sensors we have, we don't need to do anything with just one button. We just hit it, and it goes up.
So you're able to have the note go back and forth between your mechanism. Are we able to see that in motion?
Ready. So it spins one way to go up into the amp mechanism, and then he switches it, and that's all automatic.
Now, talk to me about the motion of the amp and track mechanism. Seems like it's been on an elevator. Tell me more about that.
Yeah, it's just on a two-stage elevator. It goes up, and we designed it to be able to go into the trap too. So one cool thing about it, it goes high enough to get the trap, and these protrusions push the trap door back. Originally, these plates were rounded, and we relied on the note to push the trap in. But we decided that it got caught too much, so we added these protrusions so that it would hold it off the trap.
All right, now finally, let's talk about your shooter. Seems like your shooter's not connected together. Is it run independently, both sides, or how does it run?
There's, can you hold this up, William? There's a gearbox over here with a Kraken, and there's a jack shaft that brings the chain over here. So it's one motor, but it's there's chains on both sides for rigidity.
And how has that been working out for you, relying basically on one motor?
It's been working really well. We've had no problems with it. We added these elastic bands just to reduce backlash, but other than that, there's no issues.
Now let's hand off to William to talk about your programming. Bunch of programming going on. We saw a bit of LEDs earlier, talking about the entire programming of this robot.
Yeah, so one of the philosophies that we have when we approach the software design for this robot and also robots in the past has been to alleviate a lot of the thought and pressure on the driver in the moment. So as you saw during our demonstration, there was a lot of complex movement of the note, a lot of coordination between mechanisms to get the note from one state to another and back and forth very quickly. And if the driver was doing that manually, it would be a nightmare, right? That it just during the pressure of a field and trying to compete with other robots, people just do not need to exert the brain power or should not need to exert the brain power to move the note. So we do that all in software. And as Colin mentioned, that's facilitated by a whole bunch of sensors throughout the robot. And the robot is able to keep track of the note state internally and know when it is in the shooter and the amp, vice versa, and when it is in transit. And then we can adjust our motions and make sure that the note gets to the correct place safely. That's one of the main things, actually. Safety is very important because there are a lot of places where the note can get jammed. Early on in the season, we had quite a lot of issues with the note jamming at this transition point here, the decision wheel between the amp and the shooter. But fortunately, we've refined it since then, and we no longer have that issue. And on a less hardware-specific scale, our programming is also designed to be very flexible. Our autonomous routines we have a lot of them, and we've designed them around being able to work with a lot of people in many different circumstances. So we can quickly design paths on the fly even. We've done that in competition before because we are confident enough in our abilities and the flexibility of our system, which is based off of the Choreo application. We use Choreo for path planning, but then we have a custom method for injecting our own actions during the autonomous routine that we wrote ourselves. We also have a custom logging framework, and that couples with our pit setup, actually.
Yeah, tell me about this pit setup. You have a Ethernet cable going up and down to all of these computers you just told me?
Yes, so we have a pit network. We call it the PAN, Pit Access Network. And there are 3 computers currently connected to it. There's a network switch right on the side of our electrical cart. And there used to be a computer inside, right nestled next to our batteries, which would act as a Git repository so that we could have 3 programmers working at once and coordinate efforts on code. Unfortunately, not our last match, but the match before, we did not have vision because our vision processor got fried. And we're pretty sure we undervolted it, and both of them died, the backup as well. So we took that computer and put it on the robot. So we no longer have a pit network, but we have a robot with vision, which is, I mean, we have been relying on vision a lot. And as you can see, we have 4 cameras, which are used for localization. And that is part of our software approach of making sure that the driver does not need to think about anything. They can just press the shoot button, automatically aligns, and make sure that it's in the correct position.
Now, what software and hardware are you using for your vision system?
So we are using Photon Vision. Our coprocessor right now is a B-Link, and it's nestled right there. And we have 4 cameras. I believe all 4 of them are using telescopic lenses to minimize distortion and make sure that our estimated pose is the most accurate.
Now, finally, I want to hand it off to Dominic. Dominic, you're the strategy person for this team. You've talked, William talked a bit about auto. You also want to talk a couple things about auto, but also talking about these LEDs that you have.
All right, so the LEDs that are currently on the robot are a good method of showing what the robot is currently in, like what specific score state it's going to be. During our demo earlier, did you notice how sometimes it was yellow, purple? So that would show what score state we were in. Purple would signify that we are scoring up in the speaker through the shooter system, whereas yellow would mean that the note is in the amp arm and is going to be scored in the amp. Whenever the LEDs are red, that means that it's going to score in the trap. As of right now, this is what the disabled lights look like. We reference it as a debug mode. That way, whenever we put the robot on the field, we double check everything. This light green here means that we have our vision set up, and we trigger every sensor on the robot in order to make sure that all of it's correct and everything starts in the correct position for the match.
Now these LEDs, you coated it so that it just stays, I guess, green until something breaks, essentially.
Basically, so kind of how every match we're gonna start with a note in the shooter, which is why whenever I keep my hand in here, it turns green. I take it out, it turns red. Whereas if I put my hand in front of this sensor, it turns red. I let go, it turns green. Is showing that this sensor is in the correct position, is showing the correct spot for the note.
Well, RoboBees, thank you guys so much for taking the time to walk us through your amazing robot. Love the sensors, love the shooter, love all the mechanisms you guys have. And again, congratulations on all the great success you guys have had this season, and I wish you guys the best of luck.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.